Welcome aboard my virtual space station and to the latest of our videos looking at how science is helping to tackle the planet's climate crisis. For the last century or so, humans have been messing up the Earth's precious atmosphere, that thin blue line surrounding the planet, allowing too much carbon dioxide, CO2 and other greenhouse gases into the air, leading to our planet getting hotter. One of the major culprits is transport, which is responsible for about a quarter of the globe's energy-related CO2 emissions. For more on this, let's link up with Jariah, who's down there in Britain.
Hi Scarlett, yes. My CO2 emissions come from these: cars, trucks, buses and motorbikes, or at least the ones powered by petrol and diesel. You know, it's hard to imagine modern life without these vehicles. But as well as having a large carbon footprint, they also produce different types of pollution. And they're also very noisy.
Here in the Science Museum, we can take a car journey through time and look at how our motor cars have developed since they first became popular in the early 1900s. This one, the Model T Ford, was built in 1908, and it's often said to have changed the world.
Thanks to mass production, it was the first car cheap enough for ordinary people to buy, and over 16 million were sold.
Lift up the bonnet of almost all those cars and you'd find they're powered in much the same way, by an incredibly clever invention, the internal combustion engine. In the petrol or gasoline version, the fuel is fed into a cylinder and mixed with air. The mixture is then squeezed into a small space by a piston and ignited by a spark. This controlled explosion pushes the piston back down, providing the power to turn the car's wheels. The gases produced, including CO2, are then pushed out of the engine and down the car's exhaust pipe. This process happens over and over very quickly, usually in 4 cylinders at different stages of the cycle, and has to be timed exactly for the vehicle to run smoothly. The only practical way to avoid producing these greenhouse gas emissions is by ditching the internal combustion engine completely. For instance, by replacing it with an electric engine, which produces no exhaust gases when operating.
There's nothing new about the idea of an electric car. Here, at the Science Museum Group's National Collection Centre near Swindon, I feel incredibly lucky to be riding in a really old American electric car called the Detroit Vroom.
It was first introduced in the early 1900s. This one was made in 1916.
So Heather, this was around the same time as early petrol cars. Why did electric cars lose out?
So when the Detroit Vroom was made, there were 3 main types of cars available: steam-powered, internal combustion engine and electric cars, and they each had their pros and cons. Electric cars were really popular because they were smooth, quiet and easy to drive, but they were limited, so they could only go up to around 20 miles an hour and had a range of about 80 miles before they needed charging up again. Charging could take anywhere between 8 and 16 hours,
Wow.
where it's instant to refill a petrol car.
So what kind of people drove this car?
These were really luxury cars to be driven around in towns and cities. They were marketed in particular towards women because they were very easy to start. Combustion engines, you needed to get out and actually crank a handle to turn the engine over, whereas these you could just get in and go.
So it's interesting that around 100 years later, electric cars are seen as a big part of tackling global heating. But there's a huge difference between this and this. Not only can modern electric cars perform well, if not better than petrol cars, they can travel hundreds of miles on just one charge.
There are 0 emissions as you drive, and increasingly, the electricity used to charge the car is coming from renewable sources like wind or solar power, also with no carbon emissions.
The UK and many other countries plan to stop the sale of new cars and vans that use fossil fuels in the next decade, to be largely replaced by electric vehicles. Though a big challenge for scientists and engineers is to create new practical ways to charge so many electric cars, especially for the many people who don't have their own driveway or garage. But what about other carbon-intensive forms of transport, like aircraft? At any moment, there are about 10,000 planes in the air, all flying through and polluting the atmosphere. Almost all currently use fossil fuels, typically kerosene, which comes from oil, making the aviation industry a big contributor to climate-damaging greenhouse gas emissions. Taking just one long-haul flight can create more emissions per passenger than anything else you might do in a whole year. And while the majority of people across the world do not fly at all, 1% of the world's population is responsible for more than half the carbon emissions from air travel. So, to combat climate change, we need to reduce the number of flights, alongside finding greener ways to power our aircraft. But moving over to electric planes is more of a challenge than for cars, isn't it, Jiraiya?
Yes. Here at the Science Museums, making the Modern World Gallery is Rolls-Royce's Spirit of Innovation, the world's fastest all-electric aircraft.
In 2021, the plane attempted to break the electric speed record of 213 miles an hour, which had stood for 4 years. Spirit of Innovation reached an average of 345 miles an hour, smashing the old record by 132 miles an hour. It shows that the technology is advancing fast, but it took lots of batteries, weighing 475 kilos in all, 40% of the plane's total weight. And this was still only enough power to fly for about 40 minutes. German company Volocopter has developed a 2-seater electric drone taxi, but their total range on one charge is only around 20 miles. So electric-powered flight still needs some major developments before it can be used more widely.
Making batteries light enough to power a passenger jet is such a major hurdle that some airlines are turning instead to other low-carbon solutions to replace kerosene. In November 2023, a Virgin Atlantic passenger jet took part in a world first, successfully flying from London to New York using 100% sustainable aviation fuel. The biofuel was a mixture of waste fats and plant sugars, powering the plane's existing Rolls-Royce engines. The historic flight was thought to have reduced the flight's carbon emissions by around 70%. It will take a massive effort to produce enough sustainable aviation fuel for the world's aircraft, but the aviation industry has committed to getting to net zero by 2050. So another technology they are researching is hydrogen-powered aircraft. The big plus is that hydrogen doesn't produce any carbon when it's burned as a fuel, but one of the major challenges is producing the hydrogen in the first place without lots of carbon emissions, and that's currently very expensive.
Quite a few buses in Britain and around the world are already powered by biofuels and hydrogen. Shipping, another big emitter of CO2, is also looking to go over to similar greener fuels.
And we shouldn't forget the modern equivalent of these in our battle against global warming.
Around 3/4 of trains in the UK are now electric, and as electricity gets greener, with more and more generated by renewable energy or nuclear power, it means the average train journey can have a very low carbon footprint per passenger.
Transport has a big part to play if planet Earth is to hit its target of net zero carbon emissions by 2050. As scientists develop exciting new technologies to use low-carbon fuels, we should also think about how we travel. For example, switching from flying to taking the train where possible, and of course, getting on our bikes more instead of relying on cars to take us everywhere.